Hey everyone, welcome to an episode of Tutorial Tuesdays. So here in this episode I'm going to get away from like a bunch of code writing and instead talk more philosophically. Back in the Paleolithic era when I was learning how to program, there was this mentor of mine who came up with these like 10 commandments of good code design. I've stolen a few of them and come up with many of my own. And so I wanted to go through a few of them, go through my 10 commandments. 10 commandments. This is not an exhaustive list by any means, but it is a good list of like kind of what I consider, you can kind of know from this list what I consider good code. Really, a lot of it is just gotchas, things that have screwed me in the past because I didn't do them, and I've just learned that I can't skip out on these things. Right? You have to do this stuff, or it's going to bite you in the ass at some point. It may not be today, but it will be at some point. Okay, number one. Number one is use meaningful identifier names. So identifiers are functions, identifier names. They're functions, variables, macros, everything. Microsoft just released calc.exe, which is kind of interesting. And I actually suggest you go and just start perusing some of the code. Some of the more, later code, it seems, the later code is reasonably structured and at least reasonably named. I can generally tell what things are by just reading the class name and the function name and the variable name and so on. As you dig into some of the real major legacy code, the stuff that does the actual calculations, the files there are dated 1995 to give you an idea of how old some of that stuff is. And that's those look like pure math equations. They're just old school, terribly named, hardcore old school C functions. And we've just moved past that as an industry. It's not useful, right? This kind of, this kind of variable is useless, right? I can't do anything with this. I can't do anything, with this function, right? There's nothing I can do with that. One thing, and this is actually a pet peeve of mine, so be aware of this. I may be a little crazy on this one, but you might have a template and it's just standard at this point to put a T here for type, and then we just sort of further it, there might be a U and so on, and this is just also very bad practice, right? I don't know why people are doing this. Just write it out, right? Just say type. It's fine. You're not actually typing that much more. So meaningful variable names, I should know what it is. If you look over here at just this file that I happen to have open, choose schedule entry for current time. Without reading any of the comments or anything, it's pretty clear what this function does. Crew AI component, it's pretty clear what class this belongs to, right? If I look at some of the member variables here, schedules, default schedule entry, running entry, current task. These are all pretty clear what they're doing. Right? Possible schedule entry choices. It's as you just dig through this code, you can see what's happening. Just current task. If current task, then destroy the current task and so on, right? So there's a bunch of stuff here, right? Here's my choice and potential targets. These names are reasonable. Queue event. That's the whole point. Because when I come back here, having not seen this code for 6 months or 3 months or even 1 month, I'm going to have no idea what was going on unless it's reasonably well named. So the only person that you're sort of, there's no shortcut. We all have fancy IDEs that autocomplete stuff for us. So there's no shortcut. So you have to use these meaningful identifier names. Make them meaningful. Sometimes choosing a function or variable name is one of the most important decisions you'll have to make. Maybe that's not true, but it can be. Sometimes it feels like it. 2, comment your code. Good God. I've worked with professionals where this is a thing, right? Comment your code. Now it's funny because there's a lot of different philosophies on how much is too much. On The Sims 4, we used Python as our gameplay language, and Python has a concept called docstrings, and so we use docstrings on every function. Every function had to have a docstring or it failed the code review. If you go back to my code, my typical commenting, this is a little heavier for what I tend to do. Typically, I try and comment at the top of every function, including, what does it return and that kind of stuff, especially for larger systems. And then, in general, I try and comment about once a paragraph. Because my rule of thumb, personally, sometimes if it's just a trivial function like this, like I can tell kind of what this does, right? If I have a current task and update that task, if that task is complete, choose a new task. Otherwise, just choose a new task. Okay, so this is pretty clear what's going on here. So I don't know that I would need to comment some of this stuff, but anything even remotely weird, or even just sometimes I'll just do it. I'll comment about once every block. I'll also comment in like this, schedule entry choice reserve. Like, I don't know what's good, but this works for now. Like, I'm not sure. So I'll comment like weird things that happen. There's sort of a classic one I say classic, base script component. I don't know if it's in the header file. It might be in the CPP file. These are all things out here. Something like get entity ID. Somewhere in here. Here it is. Well, you can enjoy my swearing comment. But I was having a lot of issues with Lua not working by returning larger integers. And I think it's a sort of floating point integer thing. I'm not actually sure what's going on. I never did figure it out. It sometimes gets truncated straight up. I mean, you can even read the comment that's right here. And I don't know why. This was happening when Lua Plus was being an issue. Actually, I haven't tested it in my current Lua system, so I probably should. I'm kind of waiting for Lua 5.3 for me to integrate that because they have true integers. Anyway, my point being that any kind of like weird thing that's happening, you should have some comment that really explains like, okay, here's what's going on. Comments are really important. I tend to comment more than your typical developer, but it has saved me more than once. My rule of thumb, and some developers think this is too much, but my rule of thumb is that I should generally be able to understand the flow of a function without looking at any code. Because when you're looking at code, like, you can just sort of blur your eyes. Like if I look at one of these, I can just sort of blur my eyes and just, okay, comment, no running action, so bail, unclaim the current target object if we have one, have the NPC execute the action, claim the target object if there is one, if there isn't, we can run this action. Okay, great. So I can understand kind of what's happening without even looking at the code or having to care about it. It's a lot easier to read human-readable text than it is to decipher code. It's always faster to do that. So I tend to comment enough that allows me to do that. So that's number 2. I don't think I'm going to get through all of these today. That's fine. Number 3... ... but no bullshit comments. And I admit that I do this sometimes, right? Probably you shouldn't comment a function called getPosition that literally returns some position and have a comment that says returns the position. That's a useless comment. That's just going to get out of sync or whatever. I mean, even here, probably you could say that this is a bullshit comment. It's pretty clear what I'm doing here. I don't know that I really need a comment here. That's not useful. So I should probably delete that comment. I don't know that I have any in here. But there are useless comments that can definitely come into play. Don't comment every single line. Now, again, if you're a student, your school, if you're going to my school, then I have my own policy on it. But your school might set some particular policy. But my opinion is that if you're a student, there's no such thing as over-commenting because you're just learning this stuff. Once you're a professional, you can definitely over-comment. That can happen. But in general, I prefer over-commenting to under-commenting. However, you don't want to have comments that are misleading, comments that are useless, because it's just extra stuff for people to read. Okay, number 4. Assert... This is supposed to be parentheses. Assert everything. And I mean everything. If it can fail in any way, assert it. For those who don't know, an assert is in my engine. I have my own macro, and I call it check. That's my own assert. Asserts are turned off in release mode. If I actually go to this guy, this is the actual logger, but here, this is an else. Logs are not enabled. You can see that check just basically, this is a no op. This will just be completely compiled out in its entirety. So in release mode, these don't exist whatsoever. So here I am saying there should be no way that running entry is null here. So I just do a check right before I return. Now asserts should not be used for real error checking. They should be used for things that you say this should never be false. For example, potential targets can be empty in this case. Like this could be a real runtime case. And in that case, I'm actually going to throw an error, which again in my engine only comes out in debug mode. But I try and recover gracefully, because if I didn't do this, then potential target size would be 0, so I'd be 0 to 0, and then I'm indexing potential choice. So right here, I would crash, because any index in an empty array is going to break. So instead of crashing, I bail out. So it's not a replacement for actual error checking. It is instead a way for us to say, that actually is the only assert that I happen to have in this file. But if I go, back here, I'm sure I have a whole bunch in here. Yeah, so there's one. Here's another one, right? Like, yeah, script object should never be null, or should always be nil in this case, right? Always. Same thing here. So it's that's what it's for. It's like, okay, this should never happen. Always assert it. It's really, really important to assert everything. Okay. Number 5. And this is going to be a little interesting for those who have never studied this stuff. Asymptotic awareness. Maintain asymptotic awareness. Asymptotic complexity, for those who've never heard of it, or algorithmic analysis type stuff, you might have heard it as like big O. It's a way to, maybe there's no H. It's a way to generally estimate approximate algorithm performance. So you might have like n, a sorting algorithm is typically going to be log n. And one of these days, I might do a series on some classic data structure stuff. But for now, if you don't know what this stuff is, if you haven't studied this stuff, if you're in school and you're gonna study this stuff, then great. You'll study it at some point. If you're on your own and you haven't studied this, or you're not super aware of this stuff, it's worth looking up and finding some basic data structures book to kind of go over this stuff. It's not the end-all be-all of algorithmic performance, but you should generally know how the algorithm grows as a function of the amount of data, right? If I have some array of 10,000 objects, I need to know if it grows linearly, then that means I'm going to do the work on those objects 10,000 times. If it's n log n, then it's 10,000 times the base 2 log of n. If it's n squared, then that's even worse, right? It's 10,000 times 10,000, which is generally bad. And knowing which problems represent which chunks. For example, naive collision detection is n squared because every object is testing against every other object. So it's inherently an n squared problem naively. You can make this a lot better if you really think about it, and there's various techniques for doing that. Spatial partitioning and only dirty updates and things like that. But if you just do it naively and you're just churning through it in a brute force method, it's basically an n squared problem. So you have to maintain that kind of awareness to know what you're doing. I had a student once who gave me a project. This was a design student, so he can be forgiven for this certainly. And said, "Hey, can you look at this?" And he was doing, his combat algorithm was doing a bunch of ray casts, and the number of ray casts were n to the 4th, which is alarming. And this would never happen in a real game. Now, he's a designer, so obviously he can be forgiven. He's never studied any of this kind of stuff. I was impressed that he had a cover system that looked like it was working in the first place. So, it's not a dig on him. It's just, this is why you have to maintain this kind of awareness, because this would get you fired in a game company, right? You can't do that. Okay, so it's been 15 minutes. So I'm going to stop here. There's 5 more that we'll do, and then next week I will do the other 5, the other 5 Ten Commandments. So these are the first 5, and next week we'll look at the other 5. See you soon.